Okay, everybody, this is 5-7, day 2. Today we're really going to focus our attention on this ambiguous case, the uncertainty, the unclearness, on the solving part of it. So we're going to go back over the examples that we did yesterday, and we're just going to go back and put in the solving part of it. So we're going to actually find the pieces that we need. So still thinking about how many triangles do I have, how do I know how many solutions I have, and then actually being able to find them. So I have the pictures up again for all the ones that we talked about in this part 1. The case 1 or case 2, in other words, is the angle acute or is it obtuse? If it's case 1, if it's acute, then we have to look at comparing those sides. If it's longer or shorter, the side opposite the angle. Usually in the labels that we have right now, it's A, but the labels change. So I really try to emphasize it's just the side opposite. If it's longer, there was only one triangle, but if it's shorter, then we have these 3 different possibilities. It's either none, 1, or 2 triangles. We don't know unless we actually solve for that first angle. Then we can figure out what's going on. Case 2, so much easier. Case 2, when it's obtuse, that means the side opposite has to be the longest. So if the side opposite isn't the longest, there's no triangle. If the side opposite is, there's one triangle. So being able to double check and just make sure, how many solutions do I actually have? All right, so here's what we're going to do then. I'm going to go ahead back to the examples that we did in day 1, in part 1, and we're going to talk through the solving part of it and make sure we can find the pieces that we're missing. So for this first one that we did yesterday, the first example, it was a case 1 because it was an obtuse or an acute angle, and the side opposite the angle, the 3, was shorter. So it was either none, 1, or 2. We did our law of sines and we figured out that very first angle, we got an error. What that means is if it's an error, again, we can't do a triangle, so it was none. So we really don't have anything else to solve for that one. But the bottom one, the second one, let's take a look at that one. This is as far as we got in this part 1. It was an acute angle, so again, it's case 1. The side opposite was 4, so that means it's less than the 8, so that means it's either none, 1, or 2, but I don't know until I solve. What I actually found out then when we found that first angle in this part 1, that angle B ended up to be 90 degrees. That means there's one triangle. If you look back at those pictures, there's only one way to draw a right angle. It's straight down, perpendicular distance, 90 degrees, one triangle. So what we have to do is find all the other pieces then that we don't know. So I know side A, side B, I know angle A, I now know angle B. What's left to find? Well, I don't know angle C, so I'll go ahead and do that. So we're going to add in the solve part. We're going to solve for the rest of the stuff we don't know. So angle C, pretty easy. Once you know the other 2 sides, just subtract from 180. So we're going to subtract those other 2 sides, and that'll give us, oops, 90. I'm writing the answer already. So plus 90. So our angle C would be 60 degrees. And then the last thing that you don't know is just your little c. So go ahead and set up law of sines and solve for little c. Remember to go back and use your given information so we know everything about side A and angle A, so that's what you'd want to use. So cross multiply divide, what you'd be typing into your calculator is 4 times the sine of 60 divided by the sine of 30. So our little c ends up to be, if I'm calculating this correctly, 6.9, I believe. So double check, type it in your calculator as well. So if there's a single solution, the idea is, yeah, and we know there was one triangle, but now only not knowing that, I also know how to solve for it. So I can actually find what those values are. Okay, the next one we did look like this, and I wanted to kind of talk back over this again. You know 2 sides and an angle opposite again. The angle opposite was acute, so I know it's case 1. So all that writing in green, that's what we thought about yesterday. Now, how did I know immediately that there was one triangle? The side opposite the angle you're given was 50. So kind of fill that information in on the picture here. So the angle that I knew was 28 degrees. The side opposite was 50. The other side was 20. There is no physical other way to draw that picture when that side opposite is longer. I could not draw the 50 coming back towards the 28. It would cross over the 20. It's too long. It's only one triangle. If you look back at your pictures, that's that 4th picture we have for case 1 where the side opposite is longer. Awesome. One triangle. So you're ready to go ahead and solve for all the pieces that you need. So the first thing, the only thing we can solve for is angle B. So 20 is the sine of angle B, as 50 is the sine of 28. Go ahead, pause the video for a sec, calculate angle B. So go ahead and do your calculation for angle B. So I'll write it out. So we're doing inverse because we're solving for an angle. So inverse sine, 20 times the sine of 28 divided by 50. And for angle B, I ended up with, looks like 10.8 degrees. So pretty tiny. Now that's my second angle, so now I can find the third angle. So angle C would be 180 minus the 2 angles that we now know. So angle C ends up being, go ahead and subtract, 141.2 degrees. And again, the last thing that I would need to be calculating then is little c. So we're kind of doing the same steps every single time here. Go back to the known information. So our side A and angle A. Cross multiply and divide, we'll get our little c. So you'd be typing in 50 times the sine of 141.2 divided by the sine of 28. So your little c ends up being 66.8. So again, we had a one triangle scenario. We knew that because the side opposite was longer in case one, always one triangle. So we can go ahead and solve and find out those other pieces. All right, the last one in case one that we talked about yesterday was this one. So let's kind of just recap again really quickly. Two sides and angle opposite. The angle opposite is acute, which means it's a case one again, so all that blue writing. And then we compare the sides. We always have to compare to know what scenario we have. So the side opposite is the 17 opposite, which happens to be the A, but remember the labels don't matter. It can be anything. So the side opposite is 17. It is shorter than 18. So what that means is we're back in that situation where it's none, one, or two. The only way to figure it out is to actually do some solving work. We got to figure out that first angle. The only one we can solve for is B. We did that, and we ended up getting 70.6. So what did that tell us? Well, that told us then that we were going to have two triangles because we didn't get error, which means it would be no solution. We didn't get 90, which means it was one solution. So we got this other angle measurement, the 70.6, which is acute, which means that's that first set of solutions in our two triangles. So this is going to be our first set, starting with this 70.6, and that's the acute version. I'm going to show you the pictures of this, but this is the acute triangle version because all the angles in this triangle are going to be acute. That's what acute triangle means. Not that it's just really cute to look at. All right, so first thing we're going to do is just finish off this first set of solutions. So we're going to do the same thing we did in all the other ones. Once you have this angle B, now we can find angle C. So 180 minus the 2 that we know, so 70.6 and the 63. So we can get our angle C, which for this one would be, go ahead and type it in. I think I got 46.4. And then our little c. So little c is to the sine of 46.4 as, go back to the information you're given, 17 is to the sine of 63. Cross multiply, divide. And we get little c is, go ahead and type it in. I got 13.8. So that's our first set of solutions. It's an acute triangle. All three angles are acute. It's the same as everything that we were doing before. That's our first set. Now I'm going to go to the next slide here because there's some pictures here that I want you to look at. What you basically just did is this solution one. So this is the acute triangle version, this first set of answers, the first set that we just did. So you were given the 63, you were given the 17, and you were given the 18. What you solved for first was the 70.6. Then we found our angle C, which was the 46.4 degrees. And then you found your side C, which is the 13.8. That's the solution that you just came up with that you just drew. That was the first set. It's an acute triangle. Now, here's the what if. I'm going to go ahead and get rid of this on the picture. You can leave it on yours if you want. Here's the what if. Instead of drawing the 17 going away from vertex A over here, what if I had drawn that 17 coming back towards vertex A instead? So this was my side that was 17 instead. So the triangle that I would get would be the one that I drew over here, this solution 2. So this triangle right here, the one where the 17 comes back towards vertex A instead of going away from it. I can do that because the 17 is shorter than this 18. It's going to be able to fit. It wouldn't cross over. It still makes a triangle. Now I want to direct your attention in this first picture to this green triangle right here. This green triangle, both of these legs or sides are 17. What do you call a triangle where both of the sides are equal? Starts with an I. Yep, it's isosceles. So if it's isosceles, not only are the sides equal, what else is equal? The base angles down here. So if this is 70.6 over here, then this has to be 70.6 as well. That's going to help us figure out what would this angle be then on the outside, because that's the other triangle that I just drew over here, having the 17 come back towards the vertex A instead of away. How would you calculate this angle right here if you know that the other side is 70.6? Well, it has to do with the word called supplemental. Those two angles would be supplementary. Do you remember what that means from geometry? If they're supplemental or supplementary, it means they add up to 180. They make a straight line. So together they're 180. So I can figure out my new set of solutions by calculating the supplement of that angle that I had calculated originally. So my new angle B, instead of using the 70.6, I'm going to do 180 minus 70.6, which is going to give you that 109.4 that they have labeled in the picture there, by finding the supplement. It's always the supplement of that first angle you solve for, because that's the angle that can either be acute or obtuse. It's that very first angle. It doesn't matter what the label is for it. It's always the first angle you're solving for. So solution 2 is the obtuse triangle version. So the obtuse triangle is going to generate your second set of solutions. And again, how you find it is always finding the supplement of the first angle that you solve for, that one that you have choice over. That very first angle that we solved for was angle B, so we found our new angle B. Well, now if angle B changes, then that's going to affect what else? Well, now angle C is going to change, so we're going to have a new angle C. So to calculate our new angle C, we're going to subtract off the two angles that we know. Well, we know angle B is 109.4. Angle A is still 63 degrees. That original given information can never change. That's what we know about the triangle. What's ambiguous, what's unclear, is whether this triangle is supposed to be acute or whether it could be obtuse. It can be either. So we have both sets of solutions. So our new angle C then is only 7.6. It's tiny now because look at how much bigger angle B got. Well, if angle C changes, guess what else changes? Little c. Our new little c, we're going to have to recalculate because now it's across from an angle that's only 7.6. So again, we go back to our given information, go back to your 17 over sine of 63. We're going to cross multiply and divide, and we're going to get our new little c. All right, so we divide. Our new little c would be 2.5. So it's much shorter because angle C is much smaller as well. So that second set of solutions, this is the kind of the big picture here, comes from the supplement of the very first angle you solve for, whatever letter it is. In our case, it happened to be B, but it could be anything. So we have the two different versions. So always think to yourself, I have an acute triangle, that's the one I get initially, and I have to have an obtuse one as well. The obtuse one comes from the supplement. Okay, so I want to do one kind of fresh start to finish here so we can talk about what we need to and be able to solve. So let's go ahead and take a look at this next one. So what we're going to do is just kind of start from scratch, think about what we know about the triangle. So I know, looks like two sides, and I have one angle opposite, and that angle opposite happens to be what kind of an angle? Acute or obtuse? It is acute. All of this information that I've just kind of talked through here is to help me figure out what law am I going to use? So I know that I'm going to use law of sines because I have a side that's opposite. Acute tells me that I have case 1, so I know that I'm going to be dealing with one of those 4 pictures on the left-hand side of our diagram that we were drawing there. How do I know which 4? Well, I've got to take a look at the sides. So which side is across from the angle? Look for the letters that are the same. So the side that's across from the angle is the 47. How does that compare with the other one? Well, it's shorter. Okay, that means you're in that set of 3 pictures that belong together. If it were longer, it would just be one triangle. It's shorter, so that means it's either no triangle, one triangle, or 2 triangles. I don't know yet because I haven't done any work yet to see what it is. All I know is it's none, 1, or 2. I don't know which one of those situations it is yet until I solve for that very first thing I can solve for. And if you look at the information you're given, there's only one thing you can solve for out of the chute here, and that's angle B. So let's go ahead and solve for angle B. Cross multiply, divide, take the inverse. Type it into your calculator. So go ahead, pause the video if you need to. Type it in, see what you come up with. Now, if your calculator tells you error, what would that mean? If it says error, well, that means you'd have no triangles. What if it says 90? We did one like that earlier today. If it's 90 degrees, that would be one triangle. If it says anything else, it's going to be two solutions. So this is what I got, 73.9 degrees. What that tells me is I'm going to be having two triangles because I didn't get error and I didn't get 90. So this is going to be my first set of solutions. This is the acute triangle version of my answers. So I ended up having an acute angle here. That means my picture is going to have all acute or angles in this triangle. So let's go ahead and finish off the first set. So we're going to find our angle C. Always kind of do the same thing here. So we find our angle C, which looks like it is 62.1 degrees. And then our little c, set up your law of sines. And we go back to our given information again. So 47 is to the sine of 44. Cross multiply, divide, no inverse because it's just a side length. So pause the video, go ahead, type yours in. I got 59.8. So that's our first set. That's the acute triangle. Now, the issue is, though, is we have a second set of triangles because it doesn't just have to be acute. Our second set comes from what if we wanted to draw this as an obtuse triangle? If we're going to draw it as an obtuse triangle, that means instead of having my acute angle of 73.9, I end up getting my new angle B as the supplement of that 73.9. That's where that obtuse angle comes from. It's always the supplement of that first angle you solve for. And the first one I happened to solve for was B, so I find the supplement of B. So my new angle B would be 106.1. Make sure you get an obtuse angle there. It's supposed to be an obtuse triangle. So my second set of solutions comes from taking this very first angle that we found and we find the supplement of it. But now that angle B changed, guess what? Angle C is going to have to change. So our new angle C, we're going to have to subtract off the other two that we know, which is the new angle B. And remember, A doesn't change. So it's still 44 degrees. So our new angle C, it's going to be a little bit smaller, 29.9 degrees. And if angle C changes, guess what? Poor little c is going to change as well. So we now have to compare it to the 29.9. Still use your 47 over sine of 44. Still cross multiply, divide. So 47 times the sine of 29.9 divided by the sine of 44. So our new little c, it's going to be a little shorter this time because angle C was smaller. I got 33.7. So the reason there's two sets is because I didn't get error 90 on that first angle. I got something else. So I generated this new second set of solutions, which is an obtuse triangle. So we have two sets for this one. It was a case one. Okay, so I wanted to do one from start to finish. Case two, just a quick review over that one. Case two is a little bit easier scenario because case two is a situation where the angle opposite is obtuse or right, meaning it's the biggest angle in the triangle. Pretty straightforward here. Either the side opposite is longer or it's not. So if it's longer, yeah, great, you'll have a solution. If it's not, you don't. So the two examples that we started in day one gave basically the same information. Two sides, an angle that was opposite, they were both obtuse. Okay, so let's take a look at the top one. So in the top one, it's a case two because it's obtuse. The side opposite the angle is this A, because our letters are the same, so it was the 6. Well, 6 is shorter than 9. It's smaller than the other angle or side that they gave you, which means it's physically impossible to draw that triangle. There'd be no triangles there. We can't draw that. So nothing else I need to do. But look at the bottom one, then we'll finish this one off. It's the same basic information. Two sides, angle that's opposite, it's obtuse, so it's case 2. But look at the side that's opposite. So find the matching letters here. Happen to be A. 22 is opposite. It's longer. Well, yeah, that's true. That's good. That means that you can actually draw that triangle. So if it's longer, we're going to have one triangle, one set of solutions. We solve it the same way we do all the other ones. The only thing you can solve for first is that first angle measurement, which is big B. So we'll solve for angle B first. So cross multiply, divide, take the inverse. So inverse sine of 15 times the sine of 118 divided by 22. Go ahead, pause the video if you need to type it in. I want to make sure that you try it yourself. Make sure you know what you're typing in there. So I got 37. And after you find angle B, then we can find angle C, which happens to be our third angle in this one. So we have, let's see, 37 and 118. So our angle C would be 25, I think. And then our little c, so always that last thing to find is that third side. We set up our law of sines. Again, going back to what we know, cross, multiply, divide. And we get our little c. So go ahead and type that in. And I believe what I ended up with was 10.5. Always thinking about what's reasonable, shortest leg across from smallest angle, all that good stuff. So this solving part is really just adding that piece in where, okay, I know that I have a triangle, so let me find all the pieces I don't have using law of sines. So really focusing in on the situations where law of sines is appropriate. So know if it's case 1 or case 2, compare your sides, see which one's longer, and then you can go ahead and determine what your solutions are if that's appropriate. So law of sines, ambiguous case.